Alright, so this example is for us to use the alternate form of derivative to find the slope at a given point. So in this case, the points that we looked at is negative 3, 4. So alternate form is a way for you to find the slope. Instead of have a general equation, we end up with a values. So what we're trying to do is find the slope when x is negative 3. So let's recall the alternate form, which is f prime of c equal to limit delta x approaching 0, delta x, f of c plus let's rewrite that on the bottom because you cannot see that. So let's recall again, f prime of c, that means the limit at c is limit delta x approaching 0, delta x, f of c plus delta x minus f of c. In this case, the c that we're looking at is the x values from the given point, which is negative 3. So we want to find the slope when x is negative 3. That is this question is asking you to do. So let's look at f of negative 3. If we plug it in, it should give us 16. Because when you plug it in, so we have negative 3 squared minus 2 times negative 3 plus 1, which will give you 16. Then we want to know when negative 3 plus delta x. So instead of using the x values, we actually use a number. So that would be equal to negative 3 plus delta x squared minus 2 times negative 3 plus delta x plus 1. So after we spin it out, which you should have is 16 minus 8 delta x plus delta x squared. You can expand that out on your own, just so that I can save some space here. Okay, so now what we want to find is the limit as negative 3. So that's the notation. Limit f primes at negative 3. That's called limit, or sorry, not limit, the slope at negative 3. So that would be a limit delta x approaching 0, delta x. Okay, so the first function is 16 minus a delta x plus delta x squared minus f of c, which is f of negative 3, which is 16. So in this case, you can see that the 16 cancel out. So that's equal to limit delta x approaching 0, negative a delta x plus delta x squared over delta x. Now, what we can do next would be factor out the delta x. Alright, so I'm going to take out delta x, negative 8, plus delta x over delta x. Alright, so that means we see that delta x is in common, so we can cross that out. So now that would be equal to limit delta x approaching 0, negative 8 plus delta x. And if we plug in the 0, that will be negative 8 plus 0, which is negative 8. So what we can conclude from this problem is that the slope, I'm going to write over here, the slope at negative 3 is 8. And that is what we mean by find the derivative as an actual point. Because now it tells you at negative 3, the slope will be decreasing and the slope is negative 8. Alright, for this example, we will find the slope, not just one point, but the slope at 3 different points on the function. So before we do that, let's recall the last couple of days we find a general equation for slope. So we're going to find the slope for square root of x. So let's derivative of x, limit delta x approaching 0, delta x. Okay, so the first one we can say square root of x plus delta x minus the second function, which is square root of x values. So we see that for this one we have to find the multiplied by the conjugate. So square root of x plus delta x plus square root of x over the same thing plus square root of x. Okay, I'm going to skip a couple of steps here because we have spent a lot of times doing these problems. So let's see the bottom, which is delta x, square root of x plus delta x plus square root of x. That's the denominator. So the top I would have x plus delta x minus x values. Okay, so over here I know the x value is going to cancel out. Also the delta x, and that will leave the numerator is 1. So y equal limit delta x approaching 0, 1 over square root of x plus delta x plus square root of x. Okay, if we put in a 0, that would give you 2, that would give you, I'm just ahead of myself, so that would give you square root of x plus square root of x, not 2, so that's square root of x plus square root of x, okay. What that means is, that's going to be equal to 2 square root of x. So this is what we call the general form. Okay, so this would apply for any point on that given functions. So the 3 points that we want to look at, so let's go back to look at the example, is tell you to find the point at 1, 4, and 0. So we want to find the slope. M is equal what? When we have x is 1, x is, I forgot the second point, 4, and when x is 0. So what we're going to do is we're going to use that one. We just solve the slope is 2 square root of x, or we call this as f prime of x, the slope. Alright, so when x is, so we want to find the slope when x is 1. What we do, simple, just plug in the x, substitute in the x values by 1, so that will give you 1/2. So this tells you when x is 1, the slope is 1/2. Okay, let's look for the slope when x is 4. Same thing. I plug it in or substitute in the 4. So 1 over 2 times 2, which is 1 over 4. And the last one is when the slope is 0. Alright, so this is the one thing that we want to look at is, can we find the slope when x is 0? So let's see. When x is 0, if I plug it in, square root of 0 is 0, so this is 1 over 0, which is undefined. So we can say that the slope at 0 does not exist. It's undefined, right? And so that's one of the questions that I have for you. Is it possible to find the slope at 0, 0? So from what we see, we cannot. It's undefined. But recall about this graph. I'm going to use this space over here. If you think about the graph of radical x, it looks like that. Sorry. Right? So at 0, we cannot really tell what is the slope. That is why it's undefined. Alright, so hopefully that helped you to understand slope better, what we mean by the slope at a given point. So first of all, let's go back. We recall, we find the slope, we find the general form. Then, depending on what is the x values that given to you, you substitute it in to find the slope at those points. So let's recall, at 1, the slope is 1/2. At 4, the slope is 1/4. And at 0 is undefined. So we cannot find the slope at 0. Again, you can look at the graph that tell you, I'm not sure what's going on at 0. We cannot find the slope. Alright, thank you for watching. Hopefully that you have good notes and we get ready for Monday to do some practice on this.